We're going to discuss collecting a high flow time integrated air sample. The media that we're going to collect our sample on is a 0.8 micron PCM cassette. The particular media may vary based on the project. Also, the flow rate with which we're going to sample may vary depending on the project, and also the duration of the sample may vary depending on the project. These high flow pumps like this are typically collect flow rates of about 5 to 16 liters a minute. So whenever we're setting up air sampling pumps, the first step is to set the flow rate prior to sampling. So we're going to do that, for example, with this pump. We'll have it in the location we're ready to sample. These high flow pumps require power, so we'll have to be plugged in. Sometimes it requires running extension cords. In this case, we're going to use a tripod to collect our sample. So we'll pull the tubing through here. And then this is our flow meter, our rotometer. We're going to also use a dummy media. So we're going to set our flows with this and any other pumps we have for the project using a dummy, the cassette that we'll use over and over again. So I like to label the dummy so you don't actually use it as a sample. So just write dummy on it. And then what we need to do is put our sampling media on our tubing to set it up to collect a flow. And this type of media has two caps. The direction of airflow is this way, and I'll show you in just a second. The whole cap comes off when we're sampling, and so you can see that the filter is down at the bottom of the cassette. So airflow goes this way. So we want to put it on our tubing. We need this cap in order to set the flow with this kind of a cassette. So we'll put the cap on, but remove the small cap. And then we're going to take a LoRa adapter, which is this thing right here, put it on here. So now we can measure the flow from the pump using the rotometer. So we're going to turn our rotometer on by doing that. It's ready to read once it turns on, but the way that this works is that its default is just take one reading and then stop, but we want it to continue to take multiple readings as we set the flow. So what we need to do is put it into the auto read mode. We have to hold down this read auto button until you hear a click, and now it's in the auto mode. So I'm going to turn the pump on and see where our flow is. I'm going to set it to approximately 6 liters a minute, and I'll do that by adjusting this nozzle to match the flow on our rotometer. I'm going to take several readings as I adjust it to make sure that the pump is stable. And once I have several readings in a row that are stable, then our pump will be set and ready to go. So I'm going to turn the pump on. Take an initial reading. Right now I'm at 11 liters a minute, which is much higher than where we want to be. So I'm going to use the pump to adjust it down. Get close to 6 liters a minute. Wait for my readings to stabilize. Right now they're stable at 5.96 liters a minute, which I'm happy with. So I will turn my pump off. And now I'm ready to record information about this sample. So my dummy I'll use again for the next pump, but for this particular sample location, I'm going to start filling out my air sampling field data sheet, page 1 of 1. I'm going to fill out the client, the job site, the building address, who's in the field sampling, the date, project number. In this case, I'm going to say total fibers, which is what this type of media is used. That will depend on the type of media, the type of sample that's being collected. This is an active sampling method. I'm going to take now a new media, put my unique sample ID on it. So this will be my sample for this location. I will note the sample ID, the floor, the location, the type of sample, whether it's a primary sample or a duplicate, which is 2 pumps side by side at the same location for the same duration. It could also be a field and a media blank, which I'll talk about momentarily. We want to record the pump ID. In this case, there should be an EH&E sample ID, but if not, then we can record the pump serial number, which is right here on this, right here. We want to record the rotometer ID, which in this case is the EH&E barcode EGLTR06. And then we'll want to record when we start, which will be time on. And then we also want to record our rotometer read on, which in this case is 5.96. So to set up the sample, we will remove the caps. We'll want to save these caps. In this case, I can remove the entire face cap from this, put it on, and we are ready to sample. Typically, we want to sample area samples at about a 45-degree angle so that we don't sample like this because debris could fall in. So 45 degrees is the appropriate angle. And then we're ready to go. And I start the pump, record the time on, sample for the duration of the sample, whatever that might be. It could be hours, could be minutes. And when we're done, we're going to shut the pump off. That'll be our time off. And then we're going to use the rotometer to take our off flow. We'll do this as fast as we can using the actual sample that we collected. Rotometer, we will turn the pump on. In this case, our off flow is 5.99 or actually 6 liters a minute. So we will record our off flow is 6 liters a minute. Our time off will be now, and then we can calculate the volume of the sample by averaging the on flow and the off flow and multiplying by the duration in minutes. We're done collecting our sample. We take it off the sample. We cap it, and we're done. So that's ready to go to the laboratory. When we're doing field blanks, we want to do everything to a field blank the same as a sample, except for we don't pass air through it. So what we want to do is put our sample ID on. We want to open both ends, recap them, and that's ready. Our media blank will just have a sample ID put on it, and then it's ready. Make sure that our field and media blanks are also documented on the air sampling form, and we use FB for field blank, and media blank is an MB for the QA type. So that is collecting area air samples with a high flow pump.